Hello everyone, and then welcome to another video. Okay, so in this video we'll be talking about Norton's theory. Okay, we'll be solving some questions on Norton's theory. And then in case you are new here, kindly subscribe. Okay, subscribe and hit on the bell icon so that you don't miss out on any uploaded video. Okay, without further much ado, let's just dive right into this tutorial video. So this will be a question on Norton's theory. Okay, so we have to find what the current passing through what this 3-ohm resistor. Okay, so let's see how we go about that. Okay, so let's look at the solution. So first we have to introduce what current IA or any current of that sort. Okay, so let's redraw this circuit. Okay, so we have this circuit with a 5-ohm volts. Then we represent that by what our current. Okay, so we have that, and then we have another resistor. Okay, then we have our last resistor with respective voltage. Okay, right, so we have 6 volts over here, we have 2 ohms, we have 1 ohm, and then we have a current source, that's the Norton current. Okay, let's say this IA. Okay, and then we have 1 ohm with 5 volts. Okay, so let's proceed. How do we find IA? Okay, so from here you can notice that this is pretty simple. Okay, straightforward, but first you have to introduce our currents. Okay, so let's say we have a certain I1 coming from this point. Okay, and then we have this I1, right? So we have another junction, and then we have another junction over here. Okay, so we can name here A, then this point will be B. Okay, right, so we know that this IA, right? And then let's introduce another current over here. Okay, and then we have another current I3 over here. Okay, so know that current entering a node must be equal to what the current leaving a node. Okay, so let's say this current is entering, this current is entering, this leaving. Okay, so we have I1, so let's introduce our current over here. So you have this I2. Okay, so you have I1 plus I2. Okay, so this entering, this entering, this leaving. Okay, and then maybe we have what I3 over here. Okay, so I3 will pass through this point, and then we have I2. I1 is entering, must be equal to what the current leaving. Okay, so we have what, according to Kirchhoff's law, you know that KCL, okay, will give us what current entering has to be equal to the current leaving. So we have what I1 plus I2 has to be equal to what I3 plus IN. Okay, we are trying to find our what IN. Okay, that's the same as what IA. Okay, note that IN is the same as what IA. Okay, don't be confused. Okay, so this is the same as what IN. Okay, so now let's proceed. Let's find IN. So let's make IN a subject. So you have IN is equal to what I1 plus what I2. Okay, all into brackets, and then we subtract from what I3. Okay, so keep this equation in mind. Okay, so now let's proceed. This question is pretty straightforward, so let's see how we find I1. Okay, so from here you know that we have what, from Ohm's law we have what V is equal to what IR. Okay, and then from here you know that we've been given the voltage and then the resistor, so we can find I. Okay, so we have what 6 on what 2, giving us what 3 amps. Okay, that's I1. Now let's move on to I2. Okay, so I2 we've been given what the same principle implies. Okay, we have what, we have the voltage and then we have the current. Okay, so we have what 4 on 1. Okay, giving us what 4 amps. Okay, that's also pretty straightforward. Let's look at I3. I3 is the same thing. Okay, so we have what I3 is equal to what our voltage on what resistor. Okay, so I3, we know that we've been given 5 volts and then 1 ohm. So let's find I3. Okay, so we have what 5 on 1 ohm. Okay, So that will give us what? 5 amps. Okay, so from here you can just find out what IN. Okay, you can find an IN over here. So you know that IN is equal to what? I1. Okay, I1 is what? 3 plus I2, which is what? 4. Okay, and then we have minus what? 5. Okay, so we have IN is equal to what? 2 amps. Okay, you can see that this is pretty straightforward. Okay, very straightforward. Let's move on to what? Finding RN. Okay, so finding RN, that's the Norton resistor. Okay, finding RN, you need to redraw the circuit without the what? Voltage. So we have what? This. Okay, and then we have RN over here. Okay, and then we have another resistor, and then we have our final resistor. Okay, so we have 2 ohm over here, we have 1 ohm over here, we have the RN. Okay, and then our last resistor is what? 1 ohm. So when we compare to this, you notice that it's the same thing over here. Okay, right, let's proceed. Now, in order to find our RN, okay, you'll notice that the 1 ohm and 2 ohm are in what? Right, you are correct. They are in what? Parallel. Okay, so the 2 ohm and the 1 ohm are in parallel. Okay, and then when you find that, that will also be in parallel with what? This 1 ohm. Okay, this 1 ohm and this 2 ohm are in parallel, and then once you find that, you notice that it's also in what? Parallel with this one. Okay, so this is how it will look like. Okay, so we have that. Okay, and then we have this. Okay, so we have R, and then we have what? 1 ohm. Now 2 by 1 divided by what? 2 plus 1. Okay, that's what? 2 and 3. 2 and 3 ohm will also be in what? In parallel with this 1 ohm. Okay, so when you do that, so this one will give us what? 2 on 3, because what is what? 2 times 1 on what? 2 plus 1, that's 2 on 3. Okay, so let's find this portion. Okay, so you know that 2 on 3 is in what? Parallel with 1 ohm. Okay, so we have what? 2 on 3 times 1 divided by this is still a RN. Okay, and then we have 2 on 3 plus what? 1. Okay, so that will give us what? A certain 2 on what? 5 ohm, and then that will also be equivalent to 0.4 ohms. Okay, right, so after that we just introduce our general Norton's formula. Okay, so we are finding for what? 3 ohm resistor. Okay, so we have what? RN divided by what? RN. Okay, plus the resistor we are looking at. Okay, R. Okay, that's our 3 ohm. Okay, we are looking at the current passing through the 3 ohm resistor, and then you multiply that by what? Your IN. Okay, so this will lead to what? RN being what? 0.4. Okay, from here. Okay, divided by what? 0.4, and then multiply by what? You add that to per the formula. Okay, you add that to 3 ohm, and then you multiply by what? IN. IN was what? 2 amps. Okay, 2 amperes or 2 amps. So we have what? Multiply by 2. When you do your computation, okay, we have what? The current passing through 3 ohm to be equal to what? This 0.235 amps. Okay, right, so this will be our final answer. Okay, so this will be the current passing through 3 ohm. Okay, this current. Okay, the current passing through 3 ohm will be 0.235 amps. Okay, thanks a lot for staying with me till the end of this video. Kindly subscribe, hit on the bell icon so that you don't miss out on any uploaded video, and I'll see you in the next one. Bye bye.